You cannot say, oh, you distribute the cosine through. This is all like bad stuff if you think you can distribute a cosine through here. So I wrote this down to see if you would catch the difference between these two. I know some of you saw it, some of you didn't. Because Sophia, you suggested we use this instead, right? Right off the bat? Because that's the format we have. Do y'all see the difference between the two? So this would be completely incorrect for me to go through this at all and do this at all, right? Does anyone need clarification on that? Well, this formula is correct, right? This is the formula we got today. This is a formula from 2 days ago or last class. I don't remember if that was the last class or the one before. I think it was last class. That was the sum difference formulas. Was it 2? Yeah, we did double and half last time. So it was from 2 classes ago we had this formula. Today we have this formula. And then I throw this problem up on the board from the chapter review. I put up here, look, this looks like cosine of alpha minus beta. And I tell you, hey, let's use the formula we just got today. And I threw it up here, and mostly everyone told me that that was okay. Trying to get you to see that this formula does not fit into this pattern right here. We do not have 2 separate cosines being subtracted. We have a cosine with 2 arguments inside being subtracted. That's this one from 2 classes ago. Understand the difference now? Okay. So I need to rewrite this. This is why these formulas start to become kind of a big mess in your head, because there's so many of them. And you look at these things, they look so similar to each other, and then, so you have to kind of get that all sorted out. All right, using this formula, what would this become? Cosine of arcsine of 3/5, and then close it out. That's this part right here. That's cosine alpha times cosine beta. So cosine of arc cosine of a half plus sine of alpha, which is arcsine of 3/5. And then lastly, times sine of arc cosine of 1/2. There we go. Yeah, this right here, good things are going to happen there, right? We're also going to have good things happen here. Because when you put together a function with its inverse like that, they should wipe each other out, as long as domain restrictions are maintained. And that means as long as these numbers are between -1 and 1, this is just going to spit out 3/5. Here's a plus sign times. This one's just going to spit out 1/2, and we've got times right there. So we've got 2 pieces of information that we still need to resolve. What is this, and what is this? Right? Okay. What do you think? You think you can finish that up in 10 minutes? You think you can do that? I want you to finish this up. I want you to work alone. And you may use your notes, and you may use your book. You may use anything but each other. All right? And I want to see if you can figure out the rest of this. That means all you have to do is these 2 right here. Okay, I was just a little thrown off on this because,
That's the one for the first one, cosine sine
Yeah.
0.05. And
what you mean by this is cosine
cosine
equals
equals
this.
that.
Yeah, okay, the cosine equals that, yeah. Okay, so let me see, 4 over, so you get 4/10. And 3, I believe that looks good. Yeah, because that one's a common one. So, okay. Got one person done. Let's see who else can get this. Anyone else? Did you raise your hand?
yeah. So 4 plus this one. Do you want this?
4/10, so 4/10, and then you multiply it at half, and then 3. That looks good. Who raised over here? Do you raise your hand? Yeah, that's looking right. Yeah. Yep, good. What the hell is that? No, I'm kidding with you. That's good.
It's great.
That's good, yeah. Sophia. I know you want to help, but I really want to kind of gauge where everyone is right now. Did I check yours? Did I check yours, right? Yeah. Okay.
So I got this one. I'm just kind of confused on how to get this part.
You know what? That's not an inverse sign right there.
It's not.
Look, see?
Oh my god. Okay.
Okay.
So
So what does this mean? This means,
this is an angle.
uh-huh.
So I got this part. Yeah.
So
I just
what
want-
is that angle right there? What's the angle? No, what is the angle? Cosine inverse of 1/2.
Yeah. So then you do adjacent over on this side.
So you said that cosine inverse of 1/2 is going to give you an angle, right? What is the angle? That's one of the common values. Cosine is which coordinate?
Y, not X.
X. So where's your x coordinate? 1/2. That's what that's asking. Where's your x coordinate? 1/2.
Yeah.
So at what angle? No?
I have to think about
Okay. What you got?
I don't know if am I on the right track
I think you are on the right track. I mean, you're coming up with reference triangles, and that's good. You're on the right track, okay? I mean, you are kind of headed that direction. You're just still got a ways to go, okay? So that's good and bad at the same time, because it's not like you're sitting there going like with nothing, you know? You're on the right track. I'm going to go through it, so we'll clear it up. I know you just walked in, so I'm not going to.
So I just, I'm not quite sure this is what I got so far.
Yeah, that's right. So multiply the fractions and then add them together to have the same denominator. Yeah.
That's like 2.
No. Just multiply these two fractions together.
Okay.
So like 4 times 1, 5 times 2, that's 4/10.
Okay.
Then 3 root 3 over 10. And then
then
you'll
that-
put them together. You already have a common denominator. Yeah, that's right. Okay, I think that's time. So look, this was kind of my plan on this in letting you work this alone is because, I mean, at this point we really need to kind of see where we are. You know, if you're looking at these two things and you're still like really far from where you need to be, then there's reason for concern. And if you're thumbing through your notes going, what the heck is that? I know maybe we've done that before and I need to see an example of it for me to understand what to do. That means you're far from where you need to be. This has to be something you look at and it's like, okay, I don't know if it's like anything else in life. I mean, you do enough stuff, you do enough repetition, you recognize it, you know what to do. If you're not practicing enough, it's, because I can sit here, if I just kept on going through this problem, I'm going to tell you the next step. That does not identify the fact that you don't know the next step, right?
Draw the triangle.
On this one, I need to draw a triangle.
Yeah.
Okay. On this one,
Draw a triangle.
do I need to draw a triangle?
Not necessarily.
Why don't I need a triangle here? Because this is a common, 1/2 is common. So right here, this piece right here, cosine inverse of 1/2. That is saying where is the x coordinate, right? At what angle is the x coordinate 1/2? And you have to be looking in which quadrants? First and the second. See, just listen to what I'm saying. This right here is telling you at what angle the x coordinate is 1/2, and then I'm telling you which quadrant. See, I'm leading you through the solution. You need to be able to do that yourself. That's what learning is about. So I think we're about half and half right now in this class. We've got half the students are there, and you got half the students who aren't there. So you have to make adjustments, right? Study harder if you can't put in the time, you have to start making that decision of whether or not, November is coming up. We're going to have one more exam before the drop date. One more exam. And that exam will be on a Thursday. Drop date is on the following day on a Friday. So I will post the grades Thursday night, and you will be able to make the decision Friday. All right. I'm not encouraging anyone to drop, but I mean, you have to be at a certain place at this point. Okay, back to this. This is an angle. It's an angle that lives in either the first or second quadrant. That course, first cosine. Our cosine is 1, 2, right? Right, like this. So where's the x coordinate 1/2? Where is that? Pi over 3, which is up here, right? That's it, pi over 3. And then it's saying, okay, if this is pi over 3, then what is sine of pi over 3? Root 3 over 2. So this is just root 3 over 2, no triangle needed. You could do triangle. You could, if you wanted to. But you don't need to because it's a common number. Now this one, that's not a common one. So for this one, you do need a triangle. And when I draw that triangle, which quadrant am I going to draw it in? Either quadrant 1 or 4, because it's arc sine. So my triangle's got to be in there. And it's the adjacent over the, no, it's the opposite over the hypotenuse. So, and it's sine, so it should be in the first quadrant? Yeah. So I should draw, why is it in the first quadrant? Because sine corresponds to the y coordinate, and y coordinate is positive in the first quadrant. This is a positive number. So I should label this side 3 and this side 5, right? And then you can solve for the other one. The other one's 4. So that, you use your Pythagorean, you can get that. Or just remember it's a 3, 4, 5 right triangle. All right, so this right here gives us an angle, right? This gives us some angle. I don't know what that angle is. What I do know is that that angle lives in this triangle. And now if I want cosine of it, I just want the adjacent over the hypotenuse, which is just 4/5. So now you multiply these two, then add together. So 4 times 1 is 4, 5 times 2 is 10. So 4/10 here plus 3 times root 3 over 10. They already have the same denominator. 4 plus 3 root 3 over 10 is the exact answer. Okay, it's a lot there. So I'm looking at this chapter review. It's on page 671. And it starts at number 45 and ends at number 75. I'm not giving that to you as a homework assignment. I'm just telling you that I'm looking at that right now. And I'm thinking that is a tremendously valuable exercise set right there. That is a good set of problems that if you really want to be serious about doing well, that if you can knock out those problems, I think you're in a great position. Because it really kind of summarizes everything. Starting off, now this does not go back into the last exam. This is from the end of the last exam till now. Question?
Don't you need an LCD between adding 1/2 plus 3/5, and then you're going to multiply across? I'm just wondering about my math logic. Like,
A common denominator between where?
1/2 plus 3/5. Wouldn't they have to?
Oh, order of operations, though. You have to do the multiplications before you do the additions.
Okay, excuse me.
So you've got to do those two together first, then those two together. And when you do that, you happen to get a common denominator. Right? The denominator is 10 on both of them.
Excuse me.
Yeah, no, it's good. These are good questions. All right. So we still have 20 minutes. At this point, I can work through some of these problems out of the chapter review. Some of those. Or we can just say it's a day. I think what I'll do is I'll let you decide. If you want to go, you can go. You're not going to hurt my feelings. If you leave, you're not going to hurt my feelings. But if you want to stay, I'm going to work out some problems from here. Unless everyone walks out, then I will not stay. And
You totally should. You didn't say that stuff.
yeah, I will. I'll turn off the camera. I'll turn the lights off, and I'll just start working problems by myself. It'll be fine. Yeah. Okay. So sign in. Let's pass it around. It's the 31st. You're here on Halloween. We should give you credit for that, right? Extra point, extra credit.
For the extra credit for the signs,
Yeah, yeah.
the power of 6, I didn't get all the way through. It kind of got stumped around where it's 3 cosine cubed 2x.
I said to leave the odds. If you have an odd power, to leave it.
Oh, okay, so then I
Yeah.
finished.
Then you were done. Yeah.
Okay. So you'll just write me down with extra credit or something.
Well, did you have it to turn in?
I had to rewrite it on it.
Why don't you turn it into me next time since I see it there? Turn it into me next time written on a different piece of paper.
Okay, because
Or,
one piece of paper someone gave me and I forgot to bring more for the notes, so I just used
okay. All right, once you sign in, you're free to go if you want to. The exam, I believe, is the 16th or 17th. I don't know. It's on the schedule that's getting passed around. Is it 16th? 16th. Drop date's the 17th.
So what are you doing for Halloween?
I'm going to stay here and just do problems.
In a very scary way.
No. Don't know yet. We'll see.
Wait for the janitor to walk in.
We'll see.
The boards are all just covered in math. The walls are covered in math.
Janitor, and janitor asks, what are you doing? Homework. Like, what homework? This is very hard, there's homework that you know you have.
Oh, no, I stopped when they said use the keyboard because at the time I didn't have it. Or I stopped it.
Is anyone staying? I mean, okay, you're going to stay? All right. I seriously don't want to do this if everyone's gone. I don't, not today. But so I'm going to start with number 75. I'm going to work my way backwards. Well, the homework is not what I'm talking about. If you want to take a picture of the review, you can. This is the review. It starts here.
And then for homework wise,
And it's on the schedule, and you'll have to take a picture. But take my book over there so you're out of the way. All right, so this is number 75, and the instructions here are to solve the equation. So any ideas here?
Can't sign my own cos.
We did when? You mean like recently?
Yeah.
Like today?
No, not today, but like last class.
Solve this equation. How?
Trying to make it prove that it equals to 1, right?
No, this is not an identity.
Oh, okay.
This is not an identity. This is saying solve this. Solve this. So that means you want to find the values of theta which make this true. So like, for example, if I plugged in 0, would it work? What's sine of 0?
So we have to square it.
Oh, square both sides?
Yeah.
Yeah?
Yeah.
We could try that. You're cheating, I think, Sophia.
We did it.
You're cheating. You're using your notes and stuff and stuff from the past. You're not allowed to. You have to like forget everything we've done already. No, very good. We can square both sides, right? That's one approach. That is an approach we can use right now. Why? That was a technique that we've done. We've actually done this, like a problem like this before. It wasn't this one, was it?
Oh, what's the sine plus?
It was sine plus cosine. So we squared both sides because I showed you that because I wanted to show you something that worked, right? It worked. So I'm okay with that. But let's just think about today's formulas. Could we use anything from today? Do we have anything that turns sine theta minus cosine theta into a product? Do we have anything that goes from a sum to a product?
From today, yes.
But do we have one that has sine and cosine? No, we don't. So going through your Rolodex of things to do, one of the first things you would think is, oh, can we get the left side to be a product? Okay, try the sum to product. Ah, we don't have that formula. So then you fall back on something else like, hey, why don't we try squaring both sides? And let's go for it. Let's see what happens if we square both sides. If we square the left side, and we square the right side, we now need to remember that there is a possibility that we have now introduced extraneous solutions, so we must check our answers when we're done. So when I square the left, I will get sine squared theta minus 2 sine theta cosine theta plus cosine squared theta. And that must equal 1. Now that's me actually taking sine theta minus cosine theta in parentheses and foiling out and collecting like terms. Are you all comfortable with that? Okay. Now something good, really good happens right now. Sine squared theta and cosine squared theta is 1. So we have -2 sine theta cosine theta plus 1 equals 1. Now I can subtract 1 on both sides. So -2 sine theta cosine theta is 0. I can go even a step further. I can divide both sides by -2. You get sine theta cosine theta equals 0. Any questions there? Okay. Now you set each of those to 0, right? Yes? And I don't know, let's see, the book probably wants the answers just between 0 and 2 pi. Yep, they just want the answers between 0 and 2 pi. But I would expect that you could get the general solutions here. But just between 0 and 2 pi, sine is 0 here and here, and cosine is 0 here and here. So what would be the 4 answers between 0 and 2 pi? 0, pi over 2, pi, 3 pi over 2, and then 2 pi maybe, but let's see how they have this here. They want the answers theta greater than or equal to 0, less than 2 pi. So they say it's okay to include 0, but do not include 2 pi. So we would have 0, pi over 2, pi, 3 pi over 2, and that's it.
Those would be our answers, just like
Those,
that?
yes.
Write it down, box it.
Box it up, yep. But I said make sure you know how to get the general solutions also. Because I most of the time on my tests, I just ask for general solutions. Maybe one problem I'll say between 0 and 2 pi, but the general solutions are more important to be able to get those later on than it is to just get the solutions between 0 and 2 pi. I understand it's a little more difficult to do the general solutions sometimes, but you know.
So for the general solution, is that like
If I wanted the general solution for this one, I would say I need to start at 0 and then jump around by pi, right? So I'd say theta must be 0 plus pi n, so just pi n. And then this one right here would say theta must be start at pi over 2 and jump around by pi n again, right? Like by pi. But if I look at both of them together in one answer, I can put both of these into one answer. Because I could get all, if I include these answers over here, I can start at 0 and jump around by pi over 2 instead of jumping by pi. Understand that? Okay. All right, let's look at another one. Sine 2 theta equals root 2 cosine theta. This looks like it's number 74. And then solve this. The book is saying between 0 and 2 pi again. Find the values of theta that make this true. So any recommendations here?
So sine 2 theta is 2 sine theta cosine theta.
Okay, so you want to use that double angle identity to rewrite the left side as sine 2 sine theta cosine theta.
And then divide by.
Okay, let's see. 2 sine theta cosine theta is the left side equals root 2 cosine theta. So yes, that is the double angle identity. This right here becomes this. And that was one of those big ones I said you should try and hardwire that one if you can, because that's used a lot.
What is that?
Double angle identity for sine. There's also a double angle identity for cosine, but there's 3 of them, right? There's 3 equivalent ones, and you can choose which one you want to use. Okay, so I'm with you on that. I like that idea because that makes everything have thetas, right? Instead of some of them having 2 thetas and the other ones having thetas, now they all have theta in the argument. So I'm a fan of that move. The next move is going to be a critical move, though. Divide both sides by cosine theta. All right. I want us to look at this equation real quick. Did the sign-in sheet go all the way around? Yeah. Did you need it?
We never got it.
You never got it? You weren't here. No, they weren't here.
Whoa.
They had the opportunity.
Want that Halloween?
Look at that x squared equals 4x. Okay? See this? Both sides of this equation have x, right? So if I divide through by x here and divide through by x here, the x's go away, I have 4. And the x's go away here, right? One of them, and I have what? X. So x equals 4 is the solution, right? This was the original problem. Let's check it. Does 4 squared equal 4 times 4? 4 squared equal 4 times 4. Yes, right? Okay. Yes? What's wrong with that, though? What else works?
Oh, negative.
Negative 4. Negative 4 wouldn't work, right? Because negative 4 squared is 16, and 4 times negative 4 is negative 16. How about 0? Doesn't 0 work?
Yes.
Isn't 0, this, I plug in 0 here, it's true?
Yep.
We lost that solution somehow. Why did we lose that solution? We divided both sides by x. When you divide both sides of an equation by something, you're never allowed to divide by 0. By doing this, we actually eliminated a solution. All right? So I'm trying to show you something to help you learn something here that's very valuable. When you had this equation, I know there's a temptation to divide both sides by something to make it go away. I know that temptation is very great. But instead of doing that, move everything to one side. All right? What would happen had I moved the 4x to the other side? X squared minus 4x equals 0. That's just subtracting 4x on both sides. Now look at the left side. What can you do on the left side? Factor an x out. If I factor an x out, I'm going to be left with x minus 4 here equals 0. Then I set both of those equal to 0, and when I get both of my solutions are there. Do you see that? There is a major dilemma, problem, danger zone when you divide both sides of an equation by something you cannot control, a variable. And so dividing both sides by cosine theta here, although is legitimate, we might lose some answers. So instead, we're going to bring this root 2 cosine theta to the other side. All right? And when I do that, 2 sine theta cosine theta minus root 2 cosine theta equals 0. And now you can factor out the cosine. So look, I'm glad y'all stayed, okay? Because y'all just learned something that's very valuable, very, very valuable. And just try and remember it. If you're algebraically working with an equation, always raise the red flag. When you're trying to divide through both sides by something, if you can't control it, if it's variable, then you better do it with care. Trying to move everything to one side is the better approach, because you're not going to lose solutions this way. All right, cosine theta comes out. And when I do that, Yeah. So when I pull the cosine from here, the cosine theta and cosine theta from here and here, I'm left with 2 sine theta minus root 2. Now I set both of those equal to 0. So cosine theta is 0. And then the other one is 2 sine theta minus root 2 equals 0. Yeah, the first equation, I think we're gonna be okay with this, right? Okay, the second equation, move the root 2 over, and then divide by, oops, my 2 is there still. Then divide by 2. Now, I just warned you about dividing both sides by a variable. If you divide by a number, you don't have to worry about it, because that's not going to change. The number is the number. But it's when it's something other than a constant that you have to be fearful. All right. This is saying where on the unit circle is the x-coordinate 0? It's here and here. This is saying where on the x-coordinate, where on the unit circle is your y-coordinate root 2 over 2. And that happens here, pi over 4 and 3 pi over 4. So if I just want the answers between 0 and 2 pi, the answers would be pi over 2, 3 pi over 2, pi over 4, and 3 pi over 4. If I wanted the general answers, it would be theta is pi over 2 plus pi over 2n. That's starting at pi over 2 and then jumping around by pi over 2. No, that's incorrect, Robert. What's wrong with that? It should be pi n, not pi over 2n. All right, this one over here. That one's pi over 4, right? I can't get to that one by jumping around. So I'm going to have 2 separate sets of answers. Pi over 4 plus you've got to come all the way back around to it. Okay, 2 pi n, yeah.
And then
And the other one, theta is
pi over 4
good.
plus 2 and
Good.
2 pi.
Yep. Okay. So if we wanted, again, just the answer between 0 and 2 pi, we'd have 4 answers. If we wanted the general solutions, it would be this, along with those 2. I don't think there's enough time to start another one. All right, y'all have a good Halloween, and try and get your homework, as much of it done. We'll hopefully have time to come back and look at this chapter review, but we will be starting chapter 9, Law of Sines on Thursday.
That's just application, right?
Yep. More formulas, though.
I'll give you that sign.
Yeah, bring that to me. Yep.
Will you be catching up on the homework solutions?
Man,
Next week?
I don't even want to make promises anymore. If I can, I will. Don't count on it. I mean, every single time I think I'm caught up, something's come up. And homework solution videos. Yeah. I did some, and then I think the ones for the solving equations.
Yeah, you stopped at 8.3.
Was it 8.3?
That was the last one you did.
What John Lennon said about life. So it's happening while you're busy making other plans.
Yeah. Yeah. Well, it's just this semester. I mean, I started from behind, and I've never caught up. The move. Yeah, it was the move. I mean, I just have not been able.
I did the extra credit, but I left in my other journal. I don't know.